Hello and welcome to the channel. Here is another task I borrowed from a different video channel. I only slightly modified it to avoid solving it using a common calculator. This time the right hand side of the equation is a number written with 10 ones and 10 twos. And the answer has to be given as numbers rather than expressions involving square root. It can be easily seen that the discriminant is also a 20-digit number, which cannot be entered into a common calculator without rounding it up to a floating point number having less significant digits, while powerful calculators like Wolfram Alpha are usually unavailable at a math competition. There is a way to find a square root without using a calculator. Someone unfamiliar with that can learn it from numerous textbooks and online videos. However, such a computation would take a considerable amount of time, leaving no time for other problems. So please pause the video and try to find the solution without directly involving square root calculation. Actually, we are going to solve a more general equation, where the right hand side, name it C, is a number written with n ones and the same amount of twos. Let A be the number written with just n ones. Then the number written with just n twos is of course 2a. If you succeed in expressing C in terms of a and nothing else than a, the problem is practically solved. If you haven't solved the problem yet, you have another chance to do it. We can express C as the sum of two numbers: the number written with n ones and n zeros, and the number written with just n twos. The n ones compose number a, while appending n zeros actually means multiplying the number by 10 to the power of n. So the first term is a times 10 to the power of n, while the second term is just 2a. So we've got rid of the rather annoying ellipses, and we have to get rid of n as well. But since both terms have a common factor a, I can't avoid the temptation to factor it out. There is nothing special about 10 to the power of n, but subtracting 1 from it gives a number written with n nines, and this really rings the bell, because such a number is 9 times a. In this case, 10 to the power of n plus 2 is 9a plus 3, or 3 times 3a plus 1. And to get the expression for C, we only need to multiply the obtained expression by a. So we get another factor a, meaning 3a times 3a plus 1. Now the goal is fulfilled, and we expressed C in terms of only a. And this is your last chance to solve the problem on your own. Let's get rid of everything which is no longer needed and replace the right hand side of the given equation with 3a times 3a plus 1. Now, the right hand side of the equation is the product of two consecutive numbers, 3a and 3a plus 1. The left hand side of the equation can be also represented as the product of two consecutive numbers, x and x plus 1. This allows to guess a root, x equals 3a. However, being so excited about that, you can make a mistake, forgetting that a quadratic equation actually has two roots. In fact, the second root can be guessed as well, if only we represent the right hand side as negative 3a times minus 3a minus 1. However, at a math competition you normally feel so strong and so composed that such a minor nuisance can be overlooked. Fortunately, there is a way out, using Vieta's formula. In order to use Vieta's formula, we have to rewrite the equation in the appropriate way by subtracting the right-hand side from both parts. So we have all the terms on the left-hand side, and the free term comes out with minus. Now, according to Vieta's formula, the sum of rows is minus the coefficient for x, which is 1 in our case, meaning that the sum of rows is -1. The second Vieta's equality tells that the product of roots is equal to the free term, which has minus. This time the sign is not going to change, so we write the product with minus. One of the roots is already known, x1 is 3a, so in order to find the second root, we can just divide the free term by the first root. And we find out that x2 is 3a plus 1 or negative, or minus 3a minus 1. You can choose which expression you like better. Just as a double check, let's see if the first Vieta's equation is also met. Adding up the obtained roots and get -1, exactly according to the expectation. We found both roots of the equation, but what we've got is not yet suitable as the answer, because we need certain values, not something depending on internal value a. So let's write the answer in the proper way. A is the number written with n ones, but the given equation corresponds to n equals 10. So we have 10 ones for a, and accordingly 10 threes for 3a, which is the value of x sub 1. In order to find the second root, we add 1 to the first root and negate the result, getting a negative number with 9 threes and 1 4. Now, after we've got the answer, this is. But I wonder if the equation can be solved in a standard way, using the discriminant. So let's clear the board and find the discriminant. The factor for x is 1 and it has to be squared. Now we need to subtract 4 times the main coefficient and the free term. The main coefficient is 1. The free term has minus, which subtraction turns into plus. Also, 4 is multiplied by 3, giving 12. Now we of course distribute, and surprise, 36a squared is the square of 6a. 12a can be interpreted as 2 times 6a times 1. While 1 squared is exactly what we needed to complete the full square. What remained is just using the well-known formula for the roots of the quadratic equation. So well known the formula is that I'm even not going to write it down. Just trust me that x is the fraction whose numerator is -1 plus minus opening bracket 6a plus 1 closing bracket, while the denominator is just 2. Of course, we don't need to specify absolute value for 6a plus 1, since it is obviously positive. And even if it weren't, plus minus would take care of everything. Assuming plus 4 plus minus, we get the first root, which is 3a, while substituting minus 4 plus minus brings up the second root, minus 3a minus 1. And this is really the end.